Hello, everybody. Welcome to episode 2. Done a little bit of work between last time and this time. Mainly, I created all of these files for my classes that I was talking about last time. Um, I imported those classes. I modified this slightly. Um, Rather than having a main function where I define the root object, I am defining my own root class that's inheriting from tk.tk. And so within this module, when this code runs, I initialize the root object and then I call the main loop method. And this is nicer because this root object is going to be my main application window. And then within that window, I created all of these guys, which these are going to take some arguments, which I haven't quite figured out yet, but these are the objects for each class representing the individual frames within the entire app window. And so nothing's changed with the functionality of the code. Just got to save. And then I run it. It still pops up with my TK window. There's nothing in it right now. But I'm going to work on populating these classes. All right, it's been a little while. So I wanted to share what I've worked on so far. Here in main.py, I'm setting the title of my figure window and then the dimensions of it in pixels. Within this main figure window, I'm setting up a grid, and within this, each grid cell houses the individual window. So, for example, here I'm saying row, I'm configuring the 0th, the very first row, to have a weight of 1. And what that means is this is the PowerPoint that I had kind of just made up as like a guide. I'm configuring this row to have a weight of 1. Whereas, if I come to row 6, so the 7th row is, imagine a grid that is slicing through here because these are two individual rows. So this has a weight of 1, and this has a weight of 16. Because 16 is there, and 1 is here. And what that allows you to do is these weight keyword arguments. As you resize the window, it will maintain the same proportions. So I set up row configure and column configure. And then what I did is the very first, not sure what you want to call it, the very first window that I want to initialize is this self.tips, because I'm going to be passing that object, likely passing that object into a lot of the other objects, a lot of the other classes, because those classes will need to have access to the tips window to display some type of tooltip, like um, either instructing you on what to do next or saying something like panning or zooming. So I did that, and the way this works is I initialized this tips, I created this tips class, which is just a container for displaying various tooltips. And I just have an init method, and then I assign its parent. But where most of the work happens is in this w.label frame. So I created within my widgets module, I'm creating a label frame class that's inheriting from the base TK label frame. And what I do is set up the background color, the foreground color, its X and Y position within that grid. And then DX and DY correspond to how many grid cells does that frame take up? So if dx were 3, for example, well, actually, I'll just show you. So, like for instance, this image, um, its dx is going to be 2 because I'm splitting up a grid here and here, and then its dy is also going to be, wait, I said that backwards. Its dy is 2, and then its dx, so like looking side to side, is going to be 3 because you need one grid point or one grid span for this section, and then this section, and then this section. So I was just doing a terrible job of explaining this grid thing, so I'm going to give it another shot. I'm going to use the preview window as an example. When I specify all of the grid rows and columns, they need to accommodate the smallest cell that's ever going to exist. So since my browse, calibrate, grab points, and tooltips all require kind of a small grid row, and the preview window takes up 4 of those, I need to specify 4 rows, but then when I make the preview window, it just has a row span of 4, and in this case, a column span of 2. So that's how that works, the grid geometry manager. I initialize I call super.init, which calls the init method of the class it's inheriting from. And then I call self.grid, which places that label frame within a grid. So what do I expect when I run this? I would expect to display a red background frame with white text letters that just say tips, kind of in this area of the root window. And if I run the code, that's what happens. I'm going to have to play with the exact weighting factors to get it to work just right. But what this should do is whenever I resize the window, it will maintain its geometry, which is cool. So now that we have created this label frame class, it'll be somewhat easy to go through the rest of these and initialize them. So that is what I'm going to do next. All right, you guys, time for an update. What I've done here is I've initialized all of the objects for each one of the panels that exist within my root window. It's possible, right now they all exist as separate files. It's possible I'll cram them into a single file because it's a lot of imports I have to do. But then again, the classes might get pretty large, so we'll see. It's nothing too complicated yet. So like I'll just open up one of them now. I'll just do, I don't know, grab, and each class pretty much just looks like this. Where the work is really happening is these label frames are getting made in each one of their grid positions. So right now, the app looks like this. You can see I have all my windows kind of set up where I want them. I may play with this a bit. I'm not totally jazzed about the style I have right now, but that's all just aesthetics that can change later. What's important is the framework is working. So I think the next thing to do is get to work on some of these buttons and stuff, I guess. I'll probably just start at the top, start in the browse button, get the button and the text field working, and yeah, we'll go from there. I've created a couple of more classes in my widgets file. I have a button and an entry. Both are inheriting from tk.button and tk.entry. And here is where we first start getting into the, whereas before we had the grid geometry manager. Now I'm using the pack geometry manager, which is just another way to physically arrange the widgets um, within the window. So I specify a button that has some width to it and it has some text. I still have to bind that button. We'll get to that. And then the entry field is a little bit more complicated. The way entry fields work in TK is you set the text variable keyword argument of the entry class, and that text variable needs to be a tk.stringvar, an instance of this class. And what that lets you do is you can call the .set method on this class. So since I am having an instance of this class called self.value, whenever I reference this entry, I just have to say entry.value.set and then choose the new value. These are where those two objects live. And then when I run it, this is what pops up. The geometry is not quite finished now, but I have this button that doesn't do anything, and then this entry field that also doesn't do anything, but they're both there. So I've written my very first callback function, and callbacks are pretty much the essence of any graphical application. Those are the functions that actually do things when you push a button or select something from a menu or click a radio button. And it's pretty easy. I've created the button and I do button.bind. And this is a type of event that TK is looking for, and it's saying when I press this button with number 1 being my left mouse button, it toggles to this function, this callback function. And the callback function takes in self, and then it takes in this other thing called event. I've never done anything with event. I think it just holds some other data, some type of information associated with the callback. But look at this. This is too easy. I wanted to be able to open up an Explorer window to browse the file system to look for an image to bring in, and I thought I was going to have to import OS and do some stuff with that, but as it turns out, Tkinter has the capability. I import tkinter.fileDialog, and this ask open file name function does literally exactly what I want it to do. So if I run this and click this button, look at this. Exactly what I want. Couldn't be easier. So I was really dreading this, but I think I've got to work on this canvas that's going to be hosting whatever image I load in. What I've done just now is I created this class that I'm calling image canvas, inheriting from tk.canvas. And a canvas is really kind of a blank slate for displaying some sort of graphics. In this case, I'm gonna load an image into it, but oops. This is all that it does now. This is just a blank canvas. And I've got to get this button. Oops, forgot I did that. I got to get this button to talk to this canvas, and whatever image I select, I want to open it into this canvas, have some ability to pick points that get added to a table here and a preview here. That's a lot of communication between these classes, and this is where it starts to get a little bit complicated, but had to happen eventually, and I'm going to get to work on it. So it is a couple hours later, and I got some good work done. Where we left off last time is I had this on button press method, and it opened up a dialog box asking you for an image. I'm going to go through what I've done since then in a good amount of detail because it was the first time where I actually had to do some work that was not just an existing Python method. So the first thing that I do is when the dialog box opens, you select some file from it, and that returns a string for the full file path. So, on a Linux machine, it'll be, root directory, home, user, um, so on and so forth, all the way till you get to the file. And it loads it into a string, and then I have in my image class, like the class that's actually housing where the uh, screenshot of the data is going to be living, I made a fill method inside of that class, and I just pass the file string to that method. So we're going to go to that class, which is over here in image canvas, and there's a lot going on here, but I'm going to go slow. We came in here in the fill method, and what this does is it takes the image, and currently right now it stretches it to fill the entire width and the entire height of the canvas. I'm not sure if I'm going to keep it that way because it's going to skew it a little bit. It might stretch it or compress it and it looks a little funny. um, so the first thing I do is I had to import a couple of libraries. There's a library PIL, which is Python image library, I believe. There's a couple of modules from that I had to import. And the first thing is I image.open the file name, and that returns an image object. And then I save that as an attribute of this class. So within the class that is showing the data, there exists an image object, which makes sense. And now this is where it gets a little bit tricky in that there's actually no easy way to get an image to fill an entire canvas. I had thought it would have been some type of argument like fill equals true or expand equals true. It turns out that's not the case, and you have to do it kind of manually by yourself. What's more is that whenever you resize the window, uh, Python, or excuse me, TK isn't smart enough. The canvas isn't smart enough to resize its child image, so you also have to do that yourself. And what is going on here is that I have a configure event, and what that is whenever the canvas itself either changes size or changes location on the screen. So if I move the window around or resize it, that triggers this configure callback. And so the code's going to come in here, it's going to sense that the window has changed size, and it's going to go to on configure callback, which is another method that I wrote. And the first thing it does is it checks, is self.image equals none? It is self.image equal to none, sorry. Because when I init this class, I set image equals to none. So what this is doing is if you come into this method and you resize the window, but there's no image present, it just returns. It doesn't do anything because we don't really care if the window gets resized and there's no image inside of it. But if there is an image inside of it, you have a couple options. This callback function, I mentioned earlier that I had never used one of these event parameters for a callback, but I've done it now because it's actually pretty convenient. I'm going to go to the else case uh, first. So pretend an image has already been loaded in, and I resize the window. I make it fill the screen. This event variable is going to hold some data. It holds dot width and dot height, which is super convenient because that's telling me what the new width and height of the window is. I save that as new W and new H, and then I call the resize method on the image object with new window and new H. And this is a kind of a nuance in that TK only can handle I'm going to get this wrong, a .gif, GIF or GIF, and another strange image format I hadn't heard of before. It doesn't do JPEGs or PNGs or bitmaps, so you have to kind of pass the image through this intermediary image tk.photo image, which it says here it's a Tkinter compatible photo image. So it's kind of just an intermediary step, and that returns a TK image and then a canvas.create image. What this is saying is I take the image, which remember has been resized to the entire width and height of the window, and I take position 0, 0 from the image, which is the upper left-hand corner, and I anchor it at the northwest corner of the canvas. So effectively, I take the upper left-hand corner of the image and I place it in the upper left-hand corner of the canvas, and then you get an image that fills the entire canvas. That's what the callback does. Now, when I'm initially filling the canvas, I had considered to write code similar to this down here, because when I'm initially filling the canvas, I don't have to worry about any sort of resizing, but that would have just been repeating myself. So I have here in the comments that when I initially fill the canvas, I'm doing all of this same work, so I just manually trigger the callback. And the way I differentiate is I say event equals none, because there's no callback, there's no event, it's been triggered manually. And so if I catch the case of event equal to none, rather than new W and new H being equal to event.width and height, because event doesn't exist, there's this other method I can get, which is winfo underscore width, stands for widget info, and there's a whole bunch of them. You can basically get the info of any widget that you call that method on. So that allows me to handle the case where I'm not resizing the window, but just initially placing it on the screen. And then, this language is all the same because new W and new H was set. So that's what it does. And I've tested it out, and it does it pretty well. So I am going to demonstrate. Hopefully it still works. My window pops up. My canvas is here, ready to go. And I load an image, and this being my first real experience on YouTube, I didn't want to get in any bind with anything, so I searched no copyright image, and I got this little clip art sheep. So what I would expect to happen right now is it loads in this clip art image. It's going to resize it, stretch it as necessary to fill the entire canvas. And I hit open, and that's what it does. Obviously, it looks silly because this image has been pretty severely stretched left and right, but you get the idea. And what's important right now is if I click and drag the window, it's resizing itself, which is nice. So that part, I had to do a bit more coding for that part, but I got it working. And earlier I was testing out, I had some breakpoints set in here, and I was testing it out. Like I had set a breakpoint here in VS Code, and I would open up the window and ever so slightly make it smaller, and just as I would have expected, the code was pausing at this over and over again because every time you drag that window by a pixel, this callback is going to be triggered. But you saw it's not slow. It doesn't lag a super duper amount, which is nice. So that I'm happy with that. What I do have to figure out though, as I envision being a problem, is as I'm clicking on here and placing dots, I'd imagine there's some sort of layering to this canvas that if I resize the window and the code comes in here and is basically what it's doing is drawing a new image every time. I just have to make sure to draw that image on the very bottom layer, else it would just cover up the points that have already been drawn. So that was cool. Like I said, that was the first time I had to kind of think about it, and it wasn't done automatically for me. Like when I discovered that this is all it takes to open up a dialog box, I was like, wow, that was easy. But took a little bit more effort this time around. I think I might call it for that video today. That's gonna come out to around between 20 and 30 minutes, I think, which is a good length. What I want to do, I guess what I should be doing next time is probably the next logical step is to get this calibrate routine going. And that'll be, along with that, is going to, I'll have to figure out, like I just talked about, these points and how to make sure they don't disappear on me. But yeah, so thank you guys for watching again, and I'll see you next time.